let me start over. So what you'll be doing this semester is very similar to what you did in your first semester dosage calc test. The difference is there's the addition of what are called flow rate problems, calculating an IV or an infusion rate, and we'll talk about what that is and how to do that. And if you're just coming in, please into the chat, type in your name and the campus. I believe everyone here is North Campus, but just in case someone popped in from another campus, that way I can separate who's coming in. All right. So there's a couple things. I put this together. You also have access to what I'm showing you right now. This is a review practice set that I put together for, again, primarily for Allegheny campus, but you guys are welcome to utilize it as well. It's in the OneDrive folder, and you should have received the share link with the same information that was sent to come onto this. If you don't have it, I'll type in my email address and you can email me and I will forward you the link. If for some reason the link has expired, just let me know and I'll reactivate it. Okay. So a couple things to keep in mind as a reminder. I know starting off the new year, sometimes, you know, we want to get back on track and try and remember where we are. And couple things, you know, you got to review your rounding rules when we'll kind of cover that as we're going through some of these things. Make sure you know your basic conversions. So you need to know these just like you did first semester, converting grams to milligrams, milligrams to micrograms, liters to milliliters. You might need to know how to convert pounds to kilograms, teaspoons, tablespoons, ounces, and hours. They're also into teaspoons, tablespoons, ounces, those household units into the metric conversion of milliliters. Most everything that you're doing conversion wise, if you think about it, in a hospital setting, in a clinical setting, you are you're going into the metric system. But most people come in and what do they have? They have a you know, if they're here in the United States, they're telling you pounds, they're telling you inches, they're telling you things that are more like the American standard household units, as opposed to the metric system, which is what is going to be utilized in a clinical setting. So just something to keep in mind. That's why you're doing this. There's a reason. Now, and someone could chime in and let me know, like at Boyce, they do they have to calculate the amount of fluid intake. And then so it'll say like a bowl of soup, that's like, you know, 2 pints, and then this, like, you know, a cup of this and a quart of that. And then you have to convert those to milliliters. I don't have those conversions listed here, but I can get them for you if that's something you think you might need. If it's not something you're doing at your campus, then you probably don't need to worry about it. All right. This also goes through your rounding rules. So like I said, we'll cover this as we're kind of going through some practice problems here. And then this is where I come down and do, sorry. Oh, here it is. I was looking for where I can scroll. All right. So helpful equations. I think most nursing students are familiar with this desired over have, or quantity, or desired over have times quantity. A lot of times that's probably should be written out as ordered instead of desired. Maybe I'll just change that real quick. So ordered over have, or order over available times the quantity. And so usually those are the more straightforward questions, like you have an oral suspension or you have some tablets, and you just need to know how many you're going to, either how much you're going to administer in a liquid form, or how much you're going to administer in a tablet or capsule form per day, or per dose. And order of have works great for that. Volume over time is going to be the thing that we're going to focus on a little bit more today, is that's what's associated with your flow rates, your IV infusions, your heparin infusions, your even insulin infusions, normal saline, dextrose infusions, anything that's going to come in via an IV, via, intravenous, it's going to be brought in via a flow rate. And so it's going to be helpful to know how to calculate that. Now, if you're still doing the ordered over have or ordered over available times quantity, trying to solve flow rates, you might get a little bit frustrated because a lot of times there's only two pieces of information that you need to know: the volume, specifically in milliliters, and then the time. You don't need to know necessarily quantity. You don't even really need to know about what was been ordered. You just want to know how quickly it's being administered, or how slowly or how fast. What is the rate? Kind of like the speed in your car. We don't necessarily care about what car you're driving. We just care that you're going the speed limit. So, or the speed that you're supposed to be going. I do not believe we get into drop rates this semester, but actually, you know what? We probably do. So basically, it's a drop rate is a modified flow rate in which we are now, instead of doing like just a constant flow, it's a drip. Okay, and you've probably seen that either in the clinical setting, or you've seen it in the hospital, or you've seen it on various TV shows, movies, adaptations where they show something dripping in, and a lot of times that's where you're getting like your heparin, your insulin, and even like your narcotics, your morphine and things like that. They'll be dripping in because they don't need to be constantly flowing in. They need to be titrated in at a slower rate, and that'll all make sense, like I said, when you start to kind of go through that in your clinicals and even in your classes. All right. And then if you've, I don't know if you were ever on anything with me last semester, or met with me before, but I am a big proponent of utilizing dimensional analysis. And you might hear those words and think, I hate that, or I don't like that way. Or in reality, when you're doing the ordered over have, you're doing dimensional analysis. It's just that you just learn to do, okay, I know this piece and this piece go in this order, and then I got it. Dimensional analysis is basically the same thing. It's just that instead of it only working for certain types of medications, it works for everything that you'll be doing in the nursing setting, with a few minor exceptions. But anyways, I'll actually, you'll see me utilize that, but I'll also demonstrate ordered over have. I try and demonstrate a variety of ways, because now is not the time to get you to, master a new technique that you don't feel comfortable with. I just want you to be really confident in whatever technique that you're utilizing to prepare for this test, and then make sure you crush it. So. All right, so let's get into some of these practice problems. All right, so when we see, and what I'm going to do is, I think I can open up a new blank sheet and see. You may not even be able to see this. Never mind. All right. Okay, so what I'm going to do is I have upgraded my tools here, and so I have a drawing tool that I utilize now to help me illustrate what we're looking at. And so make sure this is working. Yeah, here we go. So when we do these conversions, again, remember, these are just straightforward conversions. It's just practice. You're always going to see these types of questions on your test, even fourth semester. You're going to have some basic unit conversions. Hopefully by this semester, or even by the end of this semester, you should be able to look at this and just automatically say, the answer, which is 0.75 grams. Okay, because all I'm doing is moving the decimal 1 to actually 0.075. Sorry. So you should be able to get to that point where you could just move the decimal. But if you are not needing, or if you're not there yet, then this is a good time to practice what is known as dimensional analysis. So you know that 1 gram equals 1,000 milligrams. So you start off what they give you, which is the 75 milligrams. And if it makes you feel good, you can put it over 1. You don't have to do that, but sometimes it just helps for organizational standpoint. Okay. So what I'm going to do is, before I put any numbers in here, I'm looking at what I'm going to be trying to get rid of. I'm trying to get rid of milligrams, right? So I'm trying to cancel those out. And then I'm trying to convert that to grams. And then the next question is, do we know that conversion factor? And we do. We know that 1 gram is the same thing as 1,000 milligrams. Now, why that's helpful and why I show you this even on the easy problems is because if you can do it on the easy ones, it gives you a strategy to work on when you get to more complex questions. Okay. So 75 times 1, and then 1 times 1,000, so just multiply across top, multiply across the bottom, and then we're going to get 75 over 1,000, and we're just going to divide. So you just plug that into your calculator. Remember, you get to use a calculator on this test. And another reason we do this too, even though it's slow and tedious, and I'm taking my time with this, is because more often than not, these problems get missed because you go in the wrong direction when you're moving your decimal point. So instead of 0.075, you're putting 7,500, 75,000 even, and you're going the wrong direction. Okay. And so it's helpful to know, are we dividing by 1,000 or are we multiplying by 1,000? And then we'll get that same answer, 0.075 grams. All right, so hopefully that's helpful, just because I know that when I was learning these things and learning how to do this stuff, I probably hated it as well until it started to click and make sense. And you'll get there too. Just be patient. Okay. So I'll let you practice some of these the 1, 2, 3, 4. By the way, the keys to these are also listed in the in the OneDrive folder. So if there's ever something that you want to confirm that you got right, just make sure you look at that. So I'll let you practice those other ones. We can come back to it if somebody says, hey, can we see this again? I'm happy to do that. Does anyone need to see converting pounds to kilograms? And you can either unmute and say yes, or you can just PM or DM and just say, yes, or if nobody says anything, then I'll just move on to the next thing. Okay. So the next thing I'll do here is, now, again, this is what I don't know. Do you recall, did you have to do a like a volume intake type of question on your first test? It would have been like, your patient is, receives like, 4 ounces of Jello and 8 ounce, or, a cup of yogurt and a steak, and, and they're at some sort of, okay. All right. Do you feel pretty good about that question, that type of question, or do you need to review it? Okay. So let me pull up a practice version of that. So give me one moment. And I also have that as a practice in the Boyce review folder. So just so you know. Just give me a second because I'm gonna copy something here. Okay. All right. So for this example, it says to calculate the fluid intake for the following meal, assuming that a glass holds 8 ounces. So now you probably won't see an example like what I'm showing you here because I use things like quarter glass and half pint. I don't think you're going to see that, but if you end up seeing that, just know this will be good practice in general. Okay. So for the fluid intake for a meal such as this, where they're getting orange juice, coffee, a turkey sandwich, some Jell-O, and chocolate milk. First of all, the only thing listed there that we wouldn't calculate a volume for is going to be the turkey sandwich. Okay. Now you might say, well, Jell-O is solid, but if you've ever had Jell-O and if you leave it in your mouth, it's like having, a jelly-like drink. You start to get into more of like food versus liquid when we say like pudding or yogurt. But I would just confirm that with an instructor if you ever see that. But the other little thing that I notice, at least at some of these other places, is that they'll give you like a volume, a household volume, and that's what they're looking for you to convert. So like it didn't say like a 1 ounce turkey sandwich. It definitely could have said that, but then if you don't know this already, and this is what's one of the reasons why we use metric in the metric system as opposed to the household system, and especially in the clinical sciences, is that I could say I have a 3 ounce turkey, but that's referring to the weight of the turkey sandwich, not the volume of the turkey sandwich. So that definitely makes things a little bit more challenging. All right. So let's I'm going to come back to the orange juice. Let's do some of the more straightforward things. So first of all, what are we looking for? If we're looking for their total fluid intake, we want to make sure that we're calculating the right thing. And what we're looking for is how many milliliters of fluid are they receiving? Okay. So let's start with the more straightforward one. 6 ounces of coffee. Hopefully you remember that 1 ounce is the same thing as 30 milliliters. So all I'm going to do here is I'm not even going to do any kind of math or anything. I'm just going to multiply this by 30 milliliters. And that's going to give me 180 milliliters. So I'm doing that right off the bat, mainly because we don't need to make it extra complicated. Okay. Can I do dimensional analysis with this? Absolutely. But then you're doing it multiple times. Let's just work on keeping it simple. So any of the ounce ones, we just multiply by 30. So the gelatin dessert, I'm going to multiply 2.5 by 30. I think it's 80, but let me just double check. 30 times 2.5. I'm sorry. Clearly can't do that kind of math in my head either. At least not this morning. Is 75. Okay. Now we have to go and we have to say, okay, we have a glass of something and then we have a pint of something. The glass, it says up in the directions or in the beginning, it says a glass holds 8 ounces. This says they had a quarter glass of orange juice. Okay. So how do I figure out what a quarter of 8 ounces is? Well, there's 2 ways of doing that. You can just say, okay, well, what's 1/4 of 8? 2 plus 2 plus 2 plus 2. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. So a quarter of 8 would be 2. If you would prefer a more mathematical approach, you would just take the 1/4 times the 8 ounces. Okay, and remember, this is the same thing as saying 1 over 4, 8 over 1. So 8 divided by 4, this is where I was getting that number 2 from as well. So 2 ounces, then multiply by the volume, the conversion to milliliters. So now we'll get 60 milliliters. All right, so the sandwich, we don't need to do any kind of calculation with that. Okay, a pint. So if this as a review, so we know that a glass is 8 ounces. We also know that 1 cup is 8 ounces. 2 cups is 1 pint, and 2 pints is 1 quart. Okay. So that's helpful because then you can kind of know what some of these things are. So if we know that 1 pint is 2 cups, what do we know then about a half a pint? Half a pint is then going to be 1 cup. And then that's the same. Oops, sorry, I shouldn't have said. So 1 cup is the same thing as 8 ounces. And then we just multiply that by 30. And we get 240 milliliters. Then you're just going to add these up. So 60 plus 180 is 240, plus 240 is 480, plus 75. Is 555 milliliters. So I didn't miss something. Those are supposed to be 5s, not S's. Okay. Oh, good. Thank you, Ariana, for also confirming my answer. So if you didn't remember the cup, pint, quart, hopefully that's a good reminder. The other thing is when you're at home, and if you happen to be cooking something or baking something or using your measuring cups or things like that, or even if you drink from a water bottle, pay attention to the cups, quarts, pints. A lot of times they're listed on the same thing. And so you can make some, you can confirm that. You'll see that, oh, my 1 cup is 240 milliliters. And then when you look at your water bottle and at the 8 ounce mark, it's right below the 250 milliliter mark, because that's how they use that as a designation. So you know that it's a little bit less than 250, it's 240. And it's just a way to kind of get an idea. Now you know how much blood they take when they take out a pint of blood, right? Take 2 cups of blood. That seems like a lot, right? All right. Hopefully not taking a quart of blood. All right. So this kind of got skewed down to the next page, but it's okay. I think we're okay. So remember to read the questions. This question right here, this Dilantin question, or questions like this question are commonly missed on your test. And the reason being is that you mark it as, you give the answer in milliliters, but it asks you to do it in teaspoons. So I'm going to show you I like to call it the short way, or the quick and dirty way of doing this, and where you can eliminate extra conversions. So the first thing I'm going to take note of is that 1 teaspoon is the same thing as 5 milliliters. When I look at my label, I can see that I have available 125 per 5 milliliters. So that would be the same thing as saying 125 per teaspoon. So using ordered over half, 250 milligrams over the 125 milligrams times my quantity of 1 teaspoon. Okay. And then when I do that, I get an answer of 2 teaspoons. If you did this the alternative way, where you multiplied this by 5 instead of 1, you would have had 10 milliliters. And then you would just need to convert 10 milliliters to teaspoons. Okay. And you would do that by either doing a conversion factor, or you're just dividing by 5 milliliters to give you 2 teaspoons. If you were setting up, or if I was setting this up problem and I wanted to practice my dimensional analysis, okay, this is how I would do it. I always start with what I was ordered. I should say, I don't always start with that, but that's a good starting point, at least for these types of questions. What are we trying to get rid of? Milligrams. What are we looking for? Well, because it's an oral suspension, and we're looking for how much to give the patient, we know that they're going to be receiving it as a liquid. Now here, I did milliliters, but we could have also done teaspoons here as well, using the same strategy, since we know that 1 teaspoon is 5 ml. You don't need to set up long multiple conversions. You can kind of do some prep work beforehand. Okay. 125 milligrams, 5 ml. That would give me 10 ml. And then, like I said, you can convert that to 2 teaspoons. And the next time you bring out your measuring spoons, tablespoon, teaspoon, pay attention. It says it right on there. 5 ml on the teaspoon, 15 ml on the tablespoon. 2 15 ml tablespoons is 1 ounce. And now you're ready to cook. I don't know what I'm trying to say. Sorry, guys. Okay. Let me jump to some of the flow rate questions, just because I think you've seen a number of these, and then we can come back if there's something you want to see a little bit more clearly. Okay. I want to come back to the drop factor and just do some of these flow rate questions. Okay. And I'm trying to give myself some room to work through some of these. Okay. So I'm going to start with number 17. So the trick with flow rates is all flow rate is a volume over a time. The most common volume over time is going to be milliliters per hour. Okay. Sometimes it'll be milliliters will be written as CC, right? And if you've ever watched, like, your favorite medical dramas, I need 100 cc's stat, right? You know that CC and ml are the same thing. All right. Now, the reason I tell you this too is because I know at some campuses, they just say calculate the flow rate, and then they don't tell you milliliters per hour. So they just say calculate the flow rate, and then you don't see in milliliters per hour. On these practice sets, I do show you that. And I will tell you that that's how you know what it is because that's what you can program into the infusion pump is milliliters per hour. And if you're wondering, well, how do I know it's milliliters per hour versus drops per minute? The way you know that is they'll say something that there's a tubing or calculate the drop rate, but they'll usually be like some sort of tubing, or there'll be a picture of a tubing package, and that'll be or they'll mention something like infusion via microtubing. Then that will be your indication that there is that you're going to be doing a drop rate versus the traditional standard flow rate. All right. So believe it or not, this is a commonly missed question because students are always looking for, what am I supposed to do? Okay. What am I supposed to do with this question? How do I, what am I multiplying or dividing? You're really not multiplying or dividing anything. You're just kind of reducing. So what we're going to do is I'm going to take my volume, 120 milliliters, over the time, 90 minutes. And what I'm going to do is I need to convert that into milliliters per hour. So the more straightforward way is, yeah, I can just go ahead and convert minutes to hours. You know that in 1 hour, there are 60 minutes. Okay. And when I make that calculation, I'm going to plug into my calculator 120 times 60 equals, and I get 7,200. Then I'm just going to divide that by 90. And I'm going to get 80 milliliters. Per hour. Don't want to forget that. Okay. 80 milliliters per hour. So you can rationalize this because you can say, well, I know that 90 minutes is 1.5 hours. So I could say 120 divided by 1.5, and then I would get the same answer. Or you could try and rationalize, okay, well, if it was 120 and 90 minutes, you know, half of 90 minutes is 45 minutes, and that would be 60 milliliters. I mean, you can do this any number of ways. My hope is that I just showed you the most direct way without having to go into, but if you're doing it another way and you're getting the right answer, you're doing it right. I'm not here to tell you to do anything different. Okay. All right. You might see a question like 18 where it'll give you a volume. So it'll give you a volume of sodium chloride, 500 milliliters. It'll tell you what the infusion rate is, 125 milliliters per hour, but then it'll ask you how long will this infusion take. Okay. So now I need to manipulate the flow rate in order to figure out how much time has gone by. So the most straightforward way that I think of is just say it in your head, right? So in 1 hour, 125 milliliters is gone. In 2 hours, 125 plus 125 is 250 milliliters gone. 3 hours, 375 milliliters. 4 hours, now we're at 500 milliliters. So you can solve this without doing any kind of math, but sometimes they're not as straightforward as this. So there is a strategy for this. And what you're gonna do is, this is almost like doing ordered over half, okay? But I'm gonna show you doing this via dimensional analysis. I'm gonna take my 500 milliliters over 1. And then what I'm gonna do is, remember, because it says how long. So what am I looking for? I'm looking to get rid of milliliters, and I'm looking for hours. So my conversion factor, it's no different than using like that dilantin question where it was milligrams per teaspoon or milligrams per milliliter. This is now just milliliters per hour. We've just kind of changed what we're using as our problems for our conversion factors, what we're trying to set up. So I know that it's 1 hour, and I know that it's 125 milliliters because that's what it says. Okay. Now you might be going, can you flip this over? Sure, you can flip this over. If all we're trying to do is make a conversion, that's exactly what conversions are, is we're just trying to relate one thing, one unit to another unit. Before you do anything, you'll know you're right because you can cross out your milliliters, and then you're left with 500 divided by 125, and you'll get 4 hours. Now, if you got it the first way I said it, where you just said 125, 250, 375, 500, that's fine. You're doing that right. I just wanted to give you an alternative in case they say, like, what if it was 400 milliliters, 125 milliliters per hour? Now you're not going to get an even time. And so you want to make sure you can at least have something that's a little bit more accessible for you. All right, what about this number 19? This is, again, we're going right back to an infusion rate. Remember, this may not always be told to you, so it may not always tell you milliliters per hour, but if it does, please use that information. So what am I going to do? I'm going to take my volume over my time, and I'm just going to reduce it. So 375 divided by 3 gives me 125. I got very original with these examples, did I not? Okay, so those are your basic flow rate questions. Practice them. There are some extra examples, I think, in the OneDrive folder. There's plenty of examples online. So let me show you drop rate, because this is probably new for you as well. There we go. Okay. So with drop rate, you have what are called drop factors, and you're relating that to the already established flow rate. So there's a formula, and it's written up at the beginning, but I'll write it again here. You're going to take the flow rate, you're going to multiply it by the drop factor, and that will give you the drop rate. Now, this is where I somewhat deviate from dimensional analysis, but in all reality, this flow rate times drop factor equation, it is dimensional analysis. It's just sometimes and I've had enough, and maybe this is you, but I've had enough students that get hung up on that they can't or don't like or don't want to do dimensional analysis. I just wanted to at least let you know that you can do this. You are doing dimensional analysis, but you don't have to set it up if you feel like you don't want to set it up the way I like to set it up. Now, something you need to know about drop rate is that drop rate is going to be written like this. GTT is the abbreviation for drops. You might be wondering, well, why not DR or D? And that's because those are already taken. DR is for DROMS, which is a apothecary unit, and then D is the prefix for deci, so I guess that's probably why that's not utilized. So they went with GTT. I'm sure there's a very good specific reason for that. But anyways, it's per minute. And that's because the drops are going at a slower rate than is the flow rate. So if I were doing like a drop rate and I wanted to know like how many drops per hour, it might be some huge number because of the fact that there's so many that are coming out per minute. So like if I do 40 a minute and then I want to know, well, what is the drops per hour? Then that just turns into like, a big number, like 60 times 40 ends up being like a really big number. And so they try and keep the numbers like in the hundreds or lower. You're starting to see that at least when you're getting to the final answer of things. You might see something ordered in like big units, like 100,000 units or 25,000 units, but then ultimately you're only giving 5 milliliters or 15 milliliters or 10 milliliters. And then that's the same thing with these drops, small numbers essentially. But anyways, flow rate, remember, typically is milliliters per hour. But if it's already in minutes and we're going to minutes, you don't need to convert the flow rate milliliters per hour or milliliters per minute into the flow rate milliliters per hour, because then you're just going to convert it right back to minutes. So I'm using that as a pretense for what we're going to do here. So following this equation and also dimensional analysis, I'm going to start off with my my flow rate, 75 milliliters, 25 minutes. The temptation will be to convert minutes to hours. Do not do that. You don't need to, and the reason you don't need to is because you already know you're looking for the drop rate. Okay. And again, if it doesn't tell you GTT per minute, if it doesn't give you a blank and say GTT per minute, you can assume that you're doing flow rate because they'll say things like tubing. They'll have a picture that says 15 drops per milliliter. That's how you know that you're doing drop rate if there's no other clues or if it's not as direct. So I'm going to multiply now by my drop rate, which is 15. drops per milliliter. If you just write 75 over 25 times 15, we're all doing the same thing. Again, the reason I'm doing this is because I know that I'm canceling out my units, and then I'm left with what I'm looking for, which is drops per minute. And that's it. Then we just multiply across the top, divide by what's at the bottom, and we're going to get 45 drops per minute. Now, you may run into a question with a drop factor type question that doesn't give you the drop factor, but it usually will say microtubing. If you see the words microtubing and it doesn't tell you what the drop factor is, the drop factor for microtubing is 60 drops per milliliter. So I'm going to just write that up here. So you'll see the word microtubing. And that's the same thing as saying 60 drops per milliliter. That's the drop factor for microtubing. I apologize for my bad handwriting there. I should zoom in so I can see what I'm doing a little bit easier. All right, so there's one more flow rate question. Okay, or a drop rate question. And again, it's using a label. So this one looks a little crazy, right? Because it says 1440 cc's of dextrose 5% normal saline to be infused over 12 hours. If your tubing is labeled as below, what will the flow rate be in drops per minute? So there's a variety of ways to do this question. I'm going to show you what I think is the most direct way. Okay, so again, we always start with the flow rate. So the flow rate for this one is going to be the 1440. I know it's cc's, but I'm just going to go ahead and just write milliliters because it's the same thing. And then 12 hours. Okay. Then what I'm going to do is I'm actually going to reduce the 1440 over the 12. Okay. And the reason I'm doing that is because I want to try and put this in as simple terms as possible. So 1440 divided by 12 gives me 120 milliliters per hour. Now, because I'm doing drop factor, I'm going to do one additional step that I think will help to save some time and then prevent you from adding extra steps with multiplication. Is I'm just going to convert hours to minutes by doing this. I'm going to take 120 milliliters. I'm going to put it over 1 hour, which is the same thing as 60 minutes. And like I said, there's a variety of ways to answer this question. I'm just trying to show you like a stepwise fashion how I would approach this question just to kind of simplify it. If you might be looking at this like, man, you just made it more complicated, and I apologize for that. The alternative way is if you take the 12 hours, multiply that by 60, then you can just convert it to minutes right off the bat. We're basically doing the same thing. But notice I only had to use my calculator for this step. So I only had to use it once as opposed to using it, a couple of different times. I don't know. Maybe I'm just I don't want to use my calculator kind of person. So I have my flow rate now in milliliters per minute. I'm going to multiply by my drop factor, which is 10. I know it's 10 because it says it right down here, 10 drops per milliliter, and it has a big giant 10 there. Okay. And then I'm going to get 20 drops per minute. All right. I just want to scroll down here and just see. Do you have the reconstitution questions where you're supposed to find out what the strength is on the okay. So I'm getting a very direct yes. So let me show you, because that one's, I know, another commonly missed question compared to what I typically give you. So give me 1 second. I have that. Yep, I have an example of that. So if there's something missing and you're like, hey, why isn't this question or a question like this listed? It's probably in the Boyce practice set. So you can look at that as well. Just find it here. Okay. Here we go. So I like to go through, and even though, like, this has already been worked through, I like to change things up a little bit. All right. So the other thing I'm going to do is I'm just going to I'm going to change this question up a little bit, and we're going to make it, let's see. Yeah, 475. Yeah. All right. I'm just changing it up so you get like a fresh question, and then that way anything that I had listed there previously only applies to what was previously listed there. Okay, so on reconstitution questions, there's a couple things to pay attention to that'll help you to know that you're doing a reconstitution type question, because these can get frustrating. Okay, now if you recall on the dilantin question, it told you to calculate the dosage and that it was it was in milligrams per milliliter. So you already knew that it was liquid. Okay. Now you might be looking at this and be like, how am I supposed to know that what I'm looking for here? Because it doesn't say, it just says how much medication to give. Is it in tablets? Is it in capsules? Well, first of all, your very first clue comes in the order. It tells you intramuscular. I don't know about you, but I think it would be very difficult to shove pills and capsules into the muscle, right? So intramuscular right off the bat tells you exactly what you're looking for. You're using a syringe, you're calculating for milliliters. Okay. And if I scroll down a little bit to the image here, you'll see that there's a picture, or on the picture, it says, if I can draw on it. Okay. Oops. It says milliliters on it. Okay. So again, that tells you, it gives you an indication of what it is that we're looking for, and how and where you're going. So if you ever get stuck, you can work through that and say, oh, okay, yeah, well, it's intramuscular, so I know I'm calculating and looking for milliliters. Okay. Then the next step is, how do I do that? The other thing is, and you'll know you're dealing with a reconstitution when you see that it tells you the same order, but then it only indicates that it's 1 gram. Doesn't tell you any kind of volume. So you know right off the bat, okay, I'm dealing with a reconstitution. When you're dealing with a reconstitution, that means you have to look at the label, the rest of the label. You have to look at the directions, the things that most likely are being done and looked at by the pharmacy. But in certain situations, you might be the one doing the mixing of the reconstitution. Reconstitution just basically means that you have a powdered form of a medication that probably needs to be administered relatively soon after it's been mixed, which is why it's stored as a powder as opposed to a liquid. And you need to be using like deionized water or distilled water or sterile water in order to prepare the injection. Okay. Now notice it also tells you for intramuscular or IV use. So if this told you IV or IM, you would still do the same thing. You're still looking for milliliters because the only way we can get volume into the patient is by in a liquid form, and we do milliliters. We don't do teaspoons, we don't do ounces, we don't do pints or quarts, we do milliliters. Okay. All right. Now I'm going to look at, and it tells me in the directions, it says for IM, which is what we're doing, right? Intramuscular use, add 2.5 milliliters sterile water for injection. So it tells you what to do. You don't need that information to do the math, but it tells you what we're doing and how we're getting to the point of liquid. Shake well, provides an approximate volume of 3 milliliters. And then this is what we're looking for. This is the strength, 330 milligrams per milliliter. Okay, 330 milligrams per milliliter. And I just wanted to check something. Okay. So 330 milligrams per milliliter, that is the strength. That is our conversion factor. That is what we're looking for. The rest of the stuff is important, but it's more like safety concerns. So like the usual adult dosage is 250 to 1 gram. Okay. You can see we've ordered 475. So we're within the proper range. It tells you some storage things, but notice that it's not bold. Notice that it's not easily found. And what I think I have some pictures of labels that you can look at just, and then if you do like a Google search, you can look at and say, hey, you know, let me see some examples of, you know, reconstitution labels, and then it'll be good practice. Okay. Now that we know all the ins and outs and how to kind of figure out what we're dealing with, now it's just a matter of doing the math. So I'm going to do what you guys probably prefer to do, ordered over have. Okay. So my order is 475 milligrams. What I have available is 330 milligrams per ml. So 475 divided by 330. And I get 1.43939 repeating. Okay. And what I'm going to do is I'm just going to round that number to the nearest tenth. 1.43 is the same thing as 1.4 milliliters. 1.4 milliliters. And then I would look for that 1.4 milliliters on my syringe, and I'd shade it or mark it or things like that. Okay. So you can shade in. Go ahead, Ariana.
So I am doing it a completely different way. I'm doing W equals D times G. And the way that I was doing it was 3 mLs over 330 milligrams times 475 milligrams. And for some reason, I'm not getting 1.4.
So you don't need the 3 ml.
Oh, okay. That's why I'm getting it wrong then. Never mind.
Yeah, and I'm glad that you said that. Okay. That's why I only circled. So 3 ml is what it's basically the powder plus the 2.5 milliliters of water. So that's your total volume. You don't care about that. You care about what the concentration is. What is the strength? The strength is the 330 milligrams per milliliter.
Okay,
good question. Yeah, you're welcome. Good job. And that's something, and that's the trap, right? And you're not the only one that falls for that trap, because like I said, I've done this now a couple of times, and over the years, this question is the trap because you're trying to figure out where that information is, and there's so many numbers. I can tell you, so in a long time ago when I was in undergrad, I worked as a pharmacy technician in a pharmacy. I got really good at like looking at these things because this is what we did in the pharmacy. We would, the patient would get an order of, usually it was like a kid, they get an order for amoxicillin, the pink stuff, right? It's powderized in the pharmacy. We get the order, add the water to the line, shake it up, tell the parent how to administer it, and then keep it in the refrigerator. A lot of times though, in nursing, you're probably not doing a lot of the reconstitutions because it's probably being done in the pharmacy. However, what I've learned is that if you're working like in a nursing home or assisted living facility, you might actually do this a lot more because there may not be a pharmacist on staff. And you might have the credentials where you can do these sorts of things. So the 3 milliliters is just a total volume of 1 gram of powder plus the 2.5 milliliters of water. What you want to know is what is that concentration, which is that 330 milligrams per milliliter.
I'm glad that you taught it this way, because learning it the other way, I don't know, I find it the way that you're teaching it so much easier.
Okay,
It
good.
makes a
Yeah.
lot more sense.
And what I find is that the struggle with teaching this stuff, and then it's just trying to connect and give you a variety of ways, because you might think about it and rationalize through it completely differently than other people might. And so what seems obvious to you might not be as obvious to me. The other thing is, like, I've tried to do this too, where like, if I wanted to do it like how you were trying to incorporate the 3 milliliters, what I would do is I would take the 1 gram divided by the 3 milliliters. So the total powder in grams divided by the total volume in milliliters. So 1 gram, which is 1,000 milligrams divided by 3, is actually 333 milligrams per milliliter. So this is even an estimate, but it's usually, when we're talking about adult medications, we're within a safe range with those types of estimates. So good. I'm glad that that was helpful, and I try to simplify it. So you can practice some of these reconstitution problems. Like I said, just look for practice problems, and I think there's at least 1 or 2 others that are posted in the OneDrive folder, and I think you'll find them helpful.
So where can we find the OneDrive folder?
So here, I will put my email into, so it should have been emailed to you as a link, and it says like link to practice tests, link to my YouTube page. But if you didn't get that, I'm going to put in my email here. This recording will also be posted on YouTube, so you can reference it again. And if you came in late or later than when I said this, if you haven't already, please make sure you put your name and your campus in the chat. That way I can let your instructors know that you attended. And I actually have to jump off because I'm going to be connecting with the 240 North Campus students in a few minutes. But I want you guys to know that I am available via email if you have any additional questions. I'm also available via the review sessions that I'll be doing next week on Tuesday and Thursday, if that happens to work out. I know you have some other sessions that you're doing, but if you want to jump on, you're more than welcome to do so. Yep, you're welcome. I'm going to go ahead and turn off the recording. You're welcome. And if I don't hear from you, good luck on your test.